structure of the table this year, but we have not inserted anything. So we are trying to build this institutional database where this is where we put all the programs. We'll still populate it. We'll populate all the programs here. Then where students write assessment, we need to bring the student assessment, impute the student assessment here. Let's look at the structure of the assessment table. I think I posted the code in the group. So maybe I will bring the codes so that it will help us to see the structure. Let me see if I will be able to see let me look for the code. Okay. So I will bring the code of the last week, the code we wrote last week. So I will bring the code so that we can see what we have done. From there, we will now begin to build a relationship. So this is where we stopped last time. We said we are going to continue from relationship. So this is the code for the student table. That's the code for student table. So to create table, so I will not want to go to this, but let's look at this table that we have created so that we can use that one to recap what we did last time. Is there any table that we need to create that we have not created? We need a student table to hold our students. We need a program table to hold our program. We need assessment to hold assessment. So which other table do you think is left that we have not created? Can anyone suggest for us? I hope, can anyone hear me? Can anyone hear me?
Can anyone hear me? I can hear you, sir.
Okay. So I hope we understand the essence of the database, what is going to be used for. That is when we know what is needed and what is not needed. This data, let me explain again the essence of this database that we are doing. Not the training, this database that we are creating during this class. We are using it as a practical for the class. We are not doing theoretical. Using this database, starting it from the beginning to the end. So it's okay, we want to create a database for a training institution. So this training institution now, they have programs, different programs like data analysis, web design, graphic design, they have database management, data science, data analysis, all these IT or ICT program. That's the essence of this training institution. So they want to organize, they want a database now. So as a database administrator or even if you want to be a back-end developer or anything, but let's just look at it from the point of view of a database administrator. And a database administrator is someone who is trained or whose job or who is responsible for the design and maintenance of an institution or an organizational database, or it could even be a personal database, but you have the skills to create and manage database. So you will now be, and it's a job role. So let's put ourselves in that shoe, that we are playing the role of a database administrator. And this institution now met us so that we should create a database for them. So this is what they do. This organization now, they train students in IT skills, data analysis, data science, programming, which is back end, front end. So all these courses, so these are some of the courses they do. And they are before you enroll in that program, you have to apply, fill a form. So they want to organize this form now. So as the course of student training, they give assessments to students. So all these things need to be well recorded and well managed. So they approach us now. We have been able to create student table that holds students biodata. Then we have created the programs table. This program table now will hold all the available programs in the institution. We have also been able to create assessment table. This assessment table now will hold all the student assessments throughout the training program. So, and let's assume that this training now is not free. So, as an institution now, and as also your role now as a database administrator, which other table will you like or do you think will be helpful to this institution or to enable you accomplish the needs of this institution? We have been able to create only 3. Is there any, or these 3 can serve the purpose? Is there any other one we need? Hello?
Yeah, good evening, sir.
Hello, sir. Hello, sir.
Yes, Agnes. I can.
Can I?
Yes, you
So
can.
I want to suggest, is it possible for us to create a table for payments in case the courses, the registration for the courses, there is payment for it, or even the fees for the training? Can we
Exactly.
create a table for payments? Yes, sir.
Very good suggestion. So, Agnes has suggested payment table that will hold student fee or student payment. So, we are going to her suggestion. No, when you write something as a comment, it's just to put 2 hyphen. So, we'll put payment table. Payment, we'll put S so that can cater for many payments. So, she has suggested payment. Is there any other one again?
Yeah, good evening, sir. Can you hear me, sir?
Yes, I can hear you very well.
Okay. I want to suggest a staff table. Staff table. Since we have students table, we should also have the staff table that controls all the staff.
Very correct. We have staff. Any other suggestion again? So these 2 suggestions, these are the 2 that even me I have in mind. So which means we are moving in the same spirit. We are in the same spirit. Thank you so much. So without wasting much of the time again, we will now go straight into creating these 2 tables as part of the recap for last week, and also we'll now enter into this week business. So we'll try to be snappy or to be fast as possible. That does not mean that you should not drag my attention if I'm too fast. So to create table now, we will now use the keyword create. What are we creating? Table. What is the name of the table? Payments. So we will now open brackets and close. Open, if you just press shift, open it will automatically put open and close bracket. So we want to end it with semicolon. That is the standard. That shows the end of that command. So, but we don't want to write everything on a straight line like ID, everything on a straight line like that. it will not be human, it will not be nice to the eyes. So we will now create another line. So inside the open and close bracket, you now click inside, then press your enter key. You can press it twice so that it will create space for you, or even if it is once, then you come to the front, you press enter so that it will rearrange your work for you. So you see the first keyword is just like like indent. I don't know how they call this kind of paragraphing. So the first line is add to the margin, while other line is being indented on a very straight line. So that helps you in reading your code, or when someone wants to look at the code, your code is not messy, it's not scattered, it's well arranged. So now we are going to look at the field. So the first one, which is what we are going to use as primary key, what should that be? Should we just call it ID? Let's call it ID, because ID is like the conventional name of conventional column name. So we use ID. So what is the data type? Now we can still use integer, because this one can hold up to 30-something thousand. And if you use it like this and you discover that maybe the data is, maybe you have up to 1 million, you can change it to big integer. So, but we are just practicing with common data type, so that it will aid our understanding. Don't want to go deep immediately. Other data types, when you understand how to use this common one, you can go deeper on your own, or we can go deeper at the course of the program. So let's just use the common one that we are very familiar with. So the data after the column name, which is ID, don't mind the fact that ID is changing like a keyword. Yes, ID is a keyword, but it will still permit us to use it as a column name or field name. So the next one now is that is the data type. So we want to specify that this is the primary key. So just type primary key. Then every line is separated with comma. So we move to the next one, payment. So who are making the payments? Students. So we need to identify the student. So we will now come now to the student table and we will now create a field here that will represent student something, or that will show that this is the student. And also not forgetting normalization. Normalization, that is avoiding redundancy, that is avoiding duplicates of information in the database. So we may not put first name, last name, parent name, sponsor, all those things. No, we are not going to put that. We just pick only one thing that represents this student. So we are going to say student ID. So we are going to use this one as a student ID. So we use student ID so that when you look at it, you know that this field is related to student table. So what is the data type now? If you check, we have been using integer as, so we'll still use integer. So that is the end of that line. We'll put comma, we'll press enter again, we'll move to the next one. So why is this? When let's say this payment now, this table will be viewed in the account unit. It's not just one person sitting down to see all this information. All this information are seen in different departments. Let's say the account department will have access to this table. They don't even know student's name, but if they want to know, they can get it by using this ID. So they may, looking at your ID, they may not know the program you are. So they need to they need to have an idea of your program. So they should now be able to know which program is this student doing. That just like your department, if it were a conventional university, you will now call it department code. Which department is this student? So if you come to programs now, we have program ID. We have an ID called for program, which is a program which is the primary key that represents every program. Each program have its own unique ID that represents it. So if you look at the assessment table, we use it as program ID. So we will still use the same thing here. We will now come and type program ID. This one will enable us to know which program the student is doing. So we'll type program ID. So what is the initial data type is integer. So we'll still type integer, separated by comma. So we now have the student's ID that will help us to know other details of the student. We now have, with the program ID now, we will now know the program that the student is doing, so that we will know how much the student is supposed to pay. So which we will now think of another column again that will be useful to us. So which other one again? We will think of maybe
we can include amount or cost.
Cost. So if you check now, we have cost in a program. So each program have amount. So when once the account units get this program ID, they will be able to get through a kind of query later that we are going to move into after creating relationship. So they can get the cost here. You understand? So we may not necessarily bring the cost again. Okay, yes, this is the cost of the program, but the amount that the student is paying, you are right. So amount that the student is paying. So we'll put amount. The cost here is how much the program costs. You are correct. So let's say amount paid. So we'll do it like this. Amount. If it is two words, you use the conventional way is to use underscore. Amount paid. Then is money, so we can use. I think we can also check that. I don't know if I have shared the material. You can check the data type that is good for money. We have decimal. I think we have so many data types that are very suitable in holding money. But let's just say with numeric first. You can as well, if the money will not be more than 30-something thousand, you can still use integer or big integer. So let's say numeric first. So separate by comma. So we need another column again. When was this payment made? When was this payment made? So we will have to put date. Date of payment. So you can see that we are using, this is date, this is to hold a date. So we'll now use date. So is there any other column again that we need?
What of the status of the payment? At times, some payment can be declined, some can be processing or done. I don't know. I don't know if it's necessary.
You are very correct. So we will now say payment status. Or you can say payment verification. Or let's say use status. Payment status. So this one now, it will hold something like pending or verified. So when somebody has not made, when no data has entered, it will show pending. So let's say we can use varchar to hold this kind of thing. Sorry, varchar, which is a variable character. So we'll specify it, let's just say 20. So let's try this keyword as default. The default value will be pending. Let's see if it will work like this. If it doesn't, if we get error, we'll remove it first. So is there any other one again? So let's think of something again, another one. But if we are okay with this, we can move to the staff table. If we need to add any column again, we can come to it.
Sorry, excuse me, sir.
Yes, you can speak.
Okay, sir. Please, I just want to know if it is possible for one to use puts in case of that amount and maybe timestamp for date of payment. If floats can be used to hold the amount in cases where some amounts may have dots, naira and kobo, dollar and cents. In such case, can we use floats?
Float. So we should use float for payment for the money, right?
Yes, sir, it's what I'm suggesting. I don't know if float is also permitted.
Okay. Okay, let's try float. We are learning now. Let's assume we are all learning. Anything that don't work, we'll go back and redo it again. So since we are using this, let's just round up this. Since we are using this default value as pending, so keeping it like this, me I know we'll still get error because what does this mean? Is the database will not identify it. Look at this one as error because it's not defined. So to use something like this, you need to put it as a string, put it as a quotation. That is, put it in quotation, something like this. So something like this will work. So you now suggested that date of payment should be date stamp, time stamp, Paul, I want to clarify something. So I wanted to get the words you use so that I will clarify something why we may not use the time stamp. Because somebody may come today with the payment.
Yes, timestamp.
Let's say somebody you're collecting the payment from bank. So somebody may decide to make payment yesterday and bring the receipt today, and you want to document it in your database using the result now before you can check your online platform to see your online payment gateway to see if the money has entered. But before you now, even when they pay online, you still need your receipt. You still need to go to the account unit to change your bank receipt or whatever, teller or anything, to the school institutional receipt. That is when the payment is verified. So you will not just make payment in the bank and hold your bank teller there and you think you have paid. No, you need to go to the account unit like that. We all understand what I'm trying to say. So let's say somebody make payment and did not come that same day and you use timestamp. It will not reflect the actual date. It will only reflect the date you are creating that record. You will not be able to pick except you want to set it as default. Let's say for example now, if no date comes in now, we'll now use default. Let's say we'll use default. Sorry. Let's say we come to this date of payment now, we'll now say default. We cannot specify, even if you cannot say now or something like this. So it means if no value comes, it should use the current date. So this date should be flexible such that the accountant or the person in the account unit can select dates that you make the payment based on what you brought. We are just trying to accommodate a situation. Let's take for example, you are not coming to the institution to pay with cash only. You have the option of paying in bank, bringing your printouts from the bank to the school, or you bring cash to the school. So we are just trying to accommodate different every scenario. So we will not use that here because the account unit may not have the opportunity to impute dates. But for the amount, you suggested floats. So we can try to use floats if it will work. Are we together?
Yeah, we are together, sir.
I want us to make it interactive so that, but normally floats may not be good because no floats is just like holding a standard number. There is no standard number when they say 10 times, or let's say 2.5 times 10 raised to power. This is number in standard form. So floats might not be let's say that much suitable, because we are just trying to hold money. So we can decide to use let's say we can use decimal, numeric. So if, let's say, even if you want to specify it to a particular number of column, or sorry, a number of digits, you can still specify it. I think we have something like that in that material. So we can say let's say 10 comma 2. That means it can be 10 digits in total, but 2 digits after decimal. But this kind of thing now may not be, though it is used in accounting, but I don't know, let's not make it complex. I just want us to make it very simple so that when we flow with it very well, we'll now go into those complex aspects. So I just want us to start in a very simple form. When we advance, when we understand it, we can try to bring in the complexity in all this. You can be specifying the default value for things, but I just want us to go simple. And when we understand it, we'll now add some complexity in it. So let's quickly move to the staff table. So we are going to use the keyword create table. So what is the name of the table? We call it staff. So we call it staff. So we can open bracket just like we normally do. Then put semicolon. Then inside the bracket we'll click and bring one of the bracket down. Then we'll go back again just to create this alignment. So the first thing that we can still use ID, which is a staff ID. So we can decide to use integer again. So I say we should go simple. Later we can make it complex. So we make it primary key. So the next thing now, we can collect staff name. We can say maybe first name. So we want to make it varchar. Sorry, I made a mistake. Varchar. So after every line, we need to put comma so that we don't get syntax error. So the next one now, we use surname. So which is still varchar. Whether you type it in capital letter or small letter, it's not case sensitive. So We can say phone number, or we can just say phone. We still use, var card. So this one, no phone number when it's more than 11, even if you add the international number before, it can be more than 11. So I will use 20. All this number determine the memory allocation, how large the system will allocate memory for each of these. So anything that will not need to be much, you don't give it a much space. So what this number means is that the size of the data it will hold. So this one will hold up to 255 kilobytes. So 20, like that. Just look at it as memory size. So we need to minimize memory so that our database will perform well. So we have the first name, the surname, the phone number. We can say address. So we can still use var card. So we may not make it long, but when we have gotten what to give us some sense, then we can know what to do. So maybe let's say educational, or let's say qualification or discipline. Let's use qualification. So we need to put the qualification of every staff. So to enable you know which course to allocate to them, so you will know their discipline or specialization. So you may be a BSc holder, but even if it is in computer science, but you don't specialize in all the areas in computer science, you have your own area of specialization. So we'll still give it this, let's say the person, so that we'll have the specialization. From this specialization, and let's say a staff now came and you will want to employ somebody, you ask for all these, somebody now says, okay, I'm a BSc holder in computer science. So you are a BSc holder in computer science. It's broad, like very broad in computer science. It's very broad. Which area are you specialized? Are you specialized in data science, and data analysis, networking, computer hardware, database, or software development? So which is your specialization? The person said, no, I'm a back-end development. No, I'm a data analyst. No, I'm a system analyst. That is the area of specialization. So we have successfully created, but we have not run the code, though. We are still creating tables. So let's look at it now. Is there any let's not make it complex, even though there are other things we need to bring in, but we'll just start it like this first.
Sir, can we include rank? Whether you are a senior engineer, you are a junior engineer, or you are a data analyst, or you are rank? Or does it supersede the specialization? I don't know.
Yes. So we'll put it level. So level of experience, we just put level of S. So level of experience, so you not years of experience. So you can be junior, intermediate, or expert, just like that. So this one will also determine your rank. So let's have level of specialization. So some can be or you can be intense, like that. So let's just make it like this. So you will now, maybe at the end, you will now assign level. Maybe you have level 1, level 2, level 3. based on how, so that it will determine their payments. Not everybody will have the same payment. So let's just not stop it here. But if you have another thing that will make our work very meaningful, you can still add. Is there any other thing again?
Can I ask a question, please?
Yes.
No, I want to ask a question. Okay.
You can ask.
Okay. From the staff table, what connects this staff table with other table together? Unlike the other one you did, you reference the ID of a table, like the. Can you go up a bit, please, or go a bit? Can you go up a bit? Let me see the up part. Can you scroll, please?
Can you see it now?
Are you there?
Yes, I'm scrolling up. You said I should scroll up, right?
Yeah, okay, it's okay. Now, in it, okay. Yeah. Okay, it's okay, It's okay.
Okay.
Okay. This under the program, sorry, under the you went up too much. Oh. Just small a bit. Just go to a table after the staff table. Table after the staff table. That payment table. I just want to see its payment table, the payment table. My question is from the payment table to that one. Okay, this is fine. Now, my question is now. Yes. My question is now. From the payment table, you use the student's ID and the program ID as a point of contact to the payment table. Now, what connect this staff table with other table together as a relationship? Thank you.
Please, who is asking this question? Let me see you. Let me look at you very well. Please, what's your name? Let me see you. I was looking at the work. I didn't check your name, please. Cornelius.
This Cornelius speaking. Yes, sir. Cornelius speaking.
Thank you so much. Thank you for the question. It shows that yes, we are moving together. Yes. If you look at it, all the tables, they are connected with one another. Only the staff table is standing alone, has no connection with any other table here. So why is it like that? So that is how you think when you are designing a database. Is this an error? Is it ID? Is there something you need to tweak again? So you now look at it in reality now. Let's look at the reality now. We have Cornelius Global Enterprise. Or training institution now. Let me use you because you asked the question. For example now. So you have this your training institution. You have people who now come and apply and you train people. And you also need to keep record of your staff. So all the tables we have created, they are tables that relate with students. It has nothing to do with who is teaching them. It is just related to student transaction. Student transaction may include registration, making payments, taking assessments. So these are the transactions, the things that students will do in that institution must be captured in your database, because your database is a representation of your business logic. Else the information you will get from the database will not be useful. It must represent all the things that happen in reality. So the teacher now does not have anything to do with assessment. The teacher does not have anything with this application to learn anything there. The student, the teacher there, or the staff has nothing to do with. I don't want to say it in one way like that the student, the teacher has nothing to do with assessment. But if you look at it from this point of view, assessment has nothing to do with the staff or the teacher or the tutor. in the sense that this table is focusing on who is taking assessments, not who is assessing them. I hope you understand. Cornelius.
Yes, sir. Yes, sir. I'm following.
Okay. So this student table now, so this assessment now is focusing on who is taking the assessment, not who is assessing them. But that the way it is now, it may not be the best way. Is this simple assessment that we need to assess our database, that we are going to achieve the purpose of this database. That is when we will know if we are in the right direction. Remember from the beginning when we were taking the introduction, I said before you design anything, you must sit down and draw it. Not just drawing, you have to plan it first. The planning is, how will this one be? How will this be before you start this coding? So now we are just focusing here on who is taking the assessment, not who is assessing them. So we may decide to bring the staff ID here. This staff ID now will show who is assessing them, but it may not be the best because we have program ID here. Instead of this, we can go and create another table called course allocation. That is the table you use to allocate courses to your tutors. So in that table, that table will now relate to this. Then that table again will connect to the program table because it will have the program ID. Let's take for example, we create another table like this. Let's just create that cost allocation table. So let's call it cost allocation. This is a comment, so that when you come to here, you know that this is cost allocation. We can still decide to call it like, use this long name for the table, so that it still makes sense. So we will now say create cost allocation. So since it's two words, so I may put, you can still hyphenate it, it doesn't matter. Cost allocation. So this is where you need to allocate courses to all this stuff. So like our normal procedure, we put open brackets, we close it, then put semicolon. We need to shift one of the bracket down, then we come up again and start typing. The first this thing is the ID, which is the primary, so the ID, which will be the primary key. So which data type? We can still use integer. So we specify primary key, comma, we come again. So we put program ID here. So this one will now connect the staff. That is, instead of putting the course name or the program name, you put the ID. The program ID, so which we can still go with integer because originally it's an integer. So here, we're now going to put the program, the staff ID. So which shows the staff that is taking any of the program here. So we still go with integer, comma, we go down again. Which period? Let's say we have first semester, second semester. Let's say for example, I am taking database in that institution now. It's an example. This is first semester. By second semester, I may not be the one taking database again. So another person, so we need to take care of what time is this person taking this course. So we'll use session. You know, we in university we use academic session. So we don't want to use the keyword. So let's just say academic or training session. Let's just use academic. I don't want it. Let's just make it such that when we look at the field, we'll know what it means. Academic session. So this one can be first semester, second semester, or try if it is 3 semesters they do. But let's just take it like this is the kind of data that will come. First, second, first semester, or sorry, it can be, let's say session is yearly. So we can say 2024/2025 academic session. So we will now put this one, we'll take something like that, like 2024/2025. So we'll put what kind of data type is not, in reality it's not a date. So we can use varchar. We can make it to be, let's say 20, or let's say 50, because we want to put this academic session. So we will now put semester, because let's say I am taking this course in the 2024/2025 academic session, first semester. Then in the 2025/2026 academic session, first semester, I may not be the one taking that course again. So as we are taking note of the academic session, we are also taking note of the semester. So let me just, I think it's like this. Even if it is not correct, we'll still correct it. But let's achieve it first, we'll still correct it. Sorry, we are not supposed to open bracket yet. So now, what kind of data type will hold that kind of data? The session can be, the semester can be first, second, like that. So what kind of data type?
Are you asking if the data type for the semester?
What kind of data type should we use?
What are you expecting? Is it just 2025, 2026? That's what you're looking for.
No, semester can come first, like
Is it
first
not first
and second. No, in university or in higher.
alpha
You can
numeric?
use voucher. You can use voucher.
Okay.
You can use voucher there. You can use voucher.
All right. So let's just say 50, because we will just write first or we'll write first, or what will come in to be first or second. Any of these two is one that will be there. So which other thing that will come again? Nothing. So we have also written the code for the course allocation table. So here now, they will now have a primary key, then the program ID, the staff that is taking the program, then which session, academic session, which semester. So when you change your staff now, you can come and you can be changing your course allocation here. So these two tables are located because it has to do with staff. But you can also link this one to know when you look at a student, a program that a student is taking. Let's say the program a student is doing database management. You can view how much the student has paid, the session, the semester, and who is taking the course, the student assessment, because through the program ID, you can come to the program table. You can come to the program table. You can come to the program table. Then when you are in the program table, from this program table, okay, the program table does not have, let's look at it again. Student table, program, available program. Then we still need one table to actualize the goal of this database. We still need another table again. The table that will hold student, the program that will show the course that each student is doing. So it's becoming big. That is how you can see that one database will have up to 50 tables to ensure normalization. So when you look at it again, you will see that we have assessment. We have under assessment, we have student ID, program that the student is taking. But then outside of here, there is nothing that connects the program and students. So this program, this code, this table that will connect the program that the student is doing, that is, it will hold the program ID, the student ID. If you like, you can also put the session, or that session is not even important again. So that will now, when you want to see which program that the student is doing, the student is offering, you can just query the student table, and that table, you see the course that the student is doing. If it were a conventional university now, we will say department. We will now create department table. I don't know if, I hope we are not going too complex in this work. Are we going too complex?
No, it's going well. No.
So we need to enable us achieve.
Wow.
We don't do relationship much today. We are not in a hurry, but let's understand the principle of database creation. So what you look out for. Somebody asked that question some time ago. What you look out for when you are creating database? What will be your database that you know that is not correct? What will not be there? You will know that this thing is still not complete. So what you look out for. When we understand this now, the class may not be even long. As soon as you understand this fundamental aspects, other things is just like practicing, will be practicing now. So we should not be in a rush to say, okay, the main topic of today is relationship. The relationship matter is not even, this is what will even help us to even understand how we can establish relationship programmatically in the database. So we are still looking at what we can look out for, what should we watch out for or look out for. So we now realize that we are not taking cognizance of the fact that students are enrolling in a particular program. Even if you look at the registration table, where students will come and register, we did not specify the course they are taking. There is no course here. This student information just enter, bam. Where is he going to? We don't know. Which program is he taking? We don't know. But we are concerned. We have taken care of the payments and the assessments. We have taken care of assessment. We can assess the student based on the code. which code will be here. We don't know which code, which program code will be in this assessment. We have not taken cognizance of that yet. In the payment, we have student ID, program ID, amount paid, date paid, payment status, but we have not made any provision for where students and program, that is where we will show in the database that this is the program this student is offering. But we have linked it here already in the payment. This linking in the payment is not complete. It's just for the purpose of the account unit to see how much the student will pay. And even if we don't create the other table first, how then will the student be assigned to a program? I hope you get it now. So we need to create a table that will assign, or that will show that this student is taking this program before this other one here will make sense. The database we are creating, I deliberately say we should use that kind of project because it's very complex. To create an institutional database is complex. So I deliberately bring it. I don't want to use any simple thing. So this one is complex. So once we understand this, any other database project we are going to handle, it will be a walkover. It will be very simple for us. So that's the reason I brought this project out. Okay, so let's quickly create another table that will assign courses to students. So to permit me, I may bring it closer to students. I will bring it after the program table so that the flow will be okay. But this one is just a choice. Whether it can be the last thing, no problem. It will only matter when we are creating relationship. So that's why most persons, they will create their table, then they will create all the relationship outside of the table so that they will not get error. Because if you now establish, let's say you are establishing a relationship to a table that have not been created, you will get error. Because you are trying to establish a relationship to what does not exist. So it will give you error. So sometime, and we are going to use that approach. We'll create all our table. If that approach did not work, it's a learning process. We'll delete all our table again. But we are not going to delete the code. We'll delete the table. We'll delete this table here, but leave the code here. Then we'll now run the code. It will recreate our table back for us. So I will now make this program assessment, this course, student course. I will call it student course or student enrollment. I will call it enrollment. This one is student registration. It's just like your registry. But when you choose your course now, you have enrolled into the program. And as at the time, you may make your choice here. Maybe you create a form. Then when you are submitting it, let's say the form we see in our application, that form may be linked to many tables. It's linked to several tables. As soon as you click submit, each of the data that are needed in the different places, that is how they will be moving to all the tables that they are needed. They will move piam. That's why most time when in this modern era now, most database are accessed through application for simplicity, so that it will be easier for you. It's not all the time that you will be coming to write code, insert into table, this, that. No. As soon as you, but even if you are going to use your database with another application, that does not rule out what we are doing. You must do it like this first, so that your application will not crash. everything will do it like this, design it like this first, before you start the linking of the database to your project or to your app. So we are going to call this course, we are going to call this table as enrollment. So we always put a comment for the table. So we are going to use create table, which is a keyword. The name of the table is enrollment. So as usual, we open brackets and close. We put our semicolon. Then inside the bracket, we'll click enter. We'll come to the front of the line again. We'll press enter so that it will align well for us. So the first thing here is the enrollment ID. This one can be integer like that. It's a primary key. Integer, primary key, comma. So the next one now we need we need student ID. This one will show which program the student is offering. So let's look at this one. Will be integer because from the primary key the data type is integer. So comma, then we will now bring in program ID, which is integer, comma. So we may take cognizance of this student is offering this program in which session of your training. Let's say your training comes in session. Sometimes we view it as if it's a conventional higher institution. Sometimes we look at it as a kind of training institution, even if it's a normal like this private training institution. But they still run but they mostly call it cohorts. But we are not using cohort, we are just using session. Let's take the approach of a conventional training institution. So which session this student is doing this, because I may decide to come to your institution and register for back-end web development in the 2024-2025 academic session. Then in your 2025-2026 academic session, I may come and register for data science. So we will now put this academic session that the student took this course. If you do it in the first term, so long as you have enrolled for that course in that session, you graduate with it. So we will not say first term, second term, no, or semester, no. This one is, we want to know the session that you register for this course. So we will now say academic session. So this academic session is holding like something like 2024, 2025, 2025, 2024. Sorry, 2025, 2026, 2026, 2027. So we are going to use backup because it's not a normal date. So let's just say 20. So what else? So that's it, except there is something again. So let's look at the entire table now. We have our staff table, we have the course allocation. This course allocation takes care of allocating of course to staff, to your tutors, in which we have the primary key of this table. We have the program that the course, the program ID, which is the course that the staff will be allocated to. So the ID now shows the ID of the staff. The academic session will now show the academic session this staff is taking this course. Semester will show which semester of this session the teacher took this course. So now we have, let's see the foreign key in this table. The only foreign key in this table, we have two foreign keys, which is the program ID and the staff ID. So let's look at it that from this table now, can we get this information? Let's say we need this information. Now let me put it in a comment. Please, we are not in a rush to take that relationship. Let's just understand this, like I said earlier. So let's say we will need information of students, student info. We want to check if our table is in order. Student information. We like the student, but let me be specific. What kind of information? Student biodata. Then we also need student course. The course you want to generate reports from this your database. So in that your report, you will need something like the student course, the course the student is doing. So you also know you want to see performance of the student, which is assessment or score. You want to see the student performance. You want to see student payment details on one report. Student payments. So you also want to see the session, this student performance in a particular session. They want to see the academic session. Why am I typing wrong something? So academic session. So let me put session to it. Is it my keyboard? So student, the academic session, this student is the payment this student made. Then the tutor, the lecturer, let me put it like this so that it will be somehow correct. The lecturer who is taking the student course. So I hope this kind of information is comprehensive for reports. Right? Are we together?
We are together.
So is this information comprehensive enough? I believe it's comprehensive. So how can we get this information now? From the student, if we want to get the student biodata, we'll fetch it from the biodata table. Then the student course, because the students and the enrollment table are linked. See the course here. So it will enable us to get that information. So the student performance, let's go to assessment. Student ID is here and the course is here. The course the student is taking, the program is here, and the score is here, the grade is here. So we can get that information. So that will enable us to get student performance. Then the academic session. So when we go to course allocation, so which academic session? I think the academic session is also in this enrollment table. You see the academic session is there. So if you want to make it more detailed, you can even, let's stop at that first. We want to go simple before we go complex. So we also want to get student payment details. So with the student ID, let's see whether student ID will be found there. Payment, because student ID is found here. We can get the student payment information. Then the lecturer, how do we know the lecturer taking the students? If you come to course allocation, there is no student ID here. But because there is a program ID here that the teacher is taking, we can use this program ID that is also found in the course in enrollment. 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 You see, student ID is here. With this, because the program is here and the student ID is here, we can pass through that one and get which program the student is doing. And because the program ID is also present in course allocation, program ID here. So from here we will now know, in course allocation we have the staff ID. We will now know the ID of this staff. So to know the name of the staff, to know the name of this staff now, because we have the ID here, we can now use this ID now to go back to staff table. We can bring in the staff name here. Do we understand this connection? That is the brief explanation of relationship. But we have not yet explained the nature. How do you call this type of relationship? We have not looked at it. Do we understand it?
Yes, sir.
Okay. Do we have any question? Do we have any question? Please, if there is no question, you can just type in the question and answer session. No question, so that we'll proceed. Even if you don't want to talk, just make a comment in the question and answer session or group. The class is quiet. Is it that we are not understanding it, or I am not taking it well? Let me strategize. Maybe use a different methodology.
He is going well, sir. He is going well.
All right. Okay. So we can see. I will still continue with this methodology. I may only look at improving it. It's not bad so far. No question. All right. So let's look at the relationship now. We have looked at the nature of we have not created a table, we only wrote the code down. So we'll now look at the relationship before we create the relation. I want us to create a relationship while creating the table. But we can still go ahead and create all these tables before, then we will now bring all the relationship together and create them. But let's look at what is relationship first. Then we'll now go back and create it. Relationship, just like we have relational database coming from this relationship, is the connection or interrelationship, or is the relationship in database define how entities are related to each other in the database. Entity means something of interest. Like in this our database now, what we are keeping record of is students and our staff. So these are our entity. Some time ago we mentioned banks. Bank's entity is customer or our customers. So they keep record of customers and their transaction. So because you are something of interest to them, so they will keep your record. Your record they are keeping is the transaction you are doing is part of your record. So the transaction is not even the entity, it's not the main entity. You as a customer is there something of interest. So what you do now, whatever you do, they will now need to keep record of that. So in this now, so we have relationship. So this table, you can see this ID, this course allocation is being related in this course allocation now, you will see program ID here. You will see staff ID, which means the course allocation is related to program ID, is related to staff ID. So because this field here are primary key from another table. You know, we also define that, and that we also say that primary key they are unique in the table. They are is what identify a particular record in a table. But when a primary key is found in a table, in another table, where it is not the primary key of that table, it becomes a foreign key. So all this one now, they are foreign key. The program ID is a foreign key. The staff ID now is a foreign key here. So which means this table now becomes a child. This course allocation now, if a primary key is found in another table, that primary key is found becomes the child table. And the table that is giving out the primary key to another table becomes the parent table. So we have the child table. Child table is the table that holds or contains the primary key of another table. So the primary key of another table, otherwise also the primary key of another table. So I will put brackets, foreign key. The primary key of another table is called foreign key. Foreign key. So when a foreign key is found in a table that holds that foreign key becomes a child to who owns that foreign key. So the parent table now, parent table is the table whose primary key is found in another table. So in table relationship now you have father, you have the child, and you have the parent. Just like as a human being now, you have the gene of your father, you have the gene of your mother. There is that biological transfer from your father to you. That makes you your father's son or daughter, because there is a transfer of gene from your father to you. So that is how, if you remember in the first class, I said the relationship that exists in life, that's the kind of relationship that exists in database. It may sound funny, but that's a fact. Everything in science or in technology is a replication of what God has done. If you deviate from the principle of God, you will fail. So God has created this earthly relationship. So humans now are following this nature of relationship and replicating it in technology. If you look at everything that science and technology, all the inventions, they are a replica of what God has created. Look at aeroplane, it looks like fish. So because if you look at even helicopter, look at a particular insect that look like helicopter. Look at sheep and look at other. If you check around, you will see a creature that God created that look like sheep. All aeroplane, whether jets, whether all kinds of, whether military plane or anything, they look like a particular animal. The popular one that reigned some months ago is the B2 by the US. The B2 look like, if you look at the picture of a B2, it look like, if you look at it, you know that this thing look like a bird. It has these characteristics, and the principle of the operation is based on how God has created those animal, for aeroplane or a jet to be able to fly, it operates on the principle that bird use in flying. So the relationship in database is in line with the relationship with human being that existed among human. So you now see, that's why you now see a child, because this parent table now gave birth to that table. It exchanged, it carried its gene, which is the primary key, and give to that table. So the table becomes the child table. And the child, when there is a child, there is a father or a parent. When there is a parent, there is a child. So I hope you use this scenario to understand it. So there are types of relationship. Types of relationship. We have the one-to-one relationship. Don't forget, don't worry, I will still share this code in the group. The one-to-one relationship. This is when one record in the table is related to one record in another table. One record is related to only, let me use the word only, one record in another table. One record cannot relate to two records. So let's see if we have that kind of relationship here. Let's say for example now, you cannot take more than 2 courses. One student should take one program at a time. So in that situation now, one student will be found in the program table. Let's say in the enrollment table. So student ID cannot be twice here, because you are allowed to take only one program. So we started like 30 minutes late, but we are going to end the class in the next 8 minutes, including the question and answer parts. So in the next, I will just wrap up this, then in the next 3 minutes, then the next 5 minutes we'll take question and answer. Then tomorrow we will start creating the physical relationship in our database. So then the second type of relationship is one-to. So you can use like this, one-to-many, or you use the normal to, one-to-many relationship. This is a situation whereby one record is related to many records in another table. Let's take for example, when can such happen? Let's take for example now, one staff in the course allocation, one staff is taking 2 programs. So in the course allocation now, you will see that one ID will be appearing many times in the staff ID column, because one staff is taking more than 2 or more than 1 courses. So these are the so let me put it in writing. This is when one record is related to many records. One record is related to many records in another table. Which table is that? It will be the child table or the parent table. So we also have many to one, I think like that, yes. So we also have many to many. So this one is just the reverse. Many records related to one. It's like to and fro. So you can just use definition in this one, and what will now be is that the many record will come first. Many record related to one record. So the many to many is when many records are related to many record. This one, they are like front and back. They are opposite of one another. The most popular one is this first two. This number, whether I should number it number 1, number 2. So this number 3 and number 2, in many times or in many situations, they are not is silent. You will not hear many to 1. You will only hear this because it's just like moving from left to the right, and you're also defining from right to the left. Then a different scenario is this many to many relationship, when many records are related to many records in another table. This is when many records are related to many records. Or you can say many records are related to more than one records. Can be, so when it is more than one, it's many. In database, when something is more than one, it's many. It may not be huge amount first, no. So long as it's not one, it's many. This is when many records are related to many records in another table. Can be tables or tables. So if you like add S, those still the same. So do we have any question? We'll use 4 minutes now for question and answer. So we have successfully come to the end of today's class. I will share this code in the group, and also we have the recording, but though we are not looking at numbers, we have some about 100, getting to 100 and something or thereabout, or 80 something. But when it comes to class, we are very few. But at the end of this program, even if it is 1 or 2 that continue to the end, it's still something. So we will not wait for others. So thank you for coming up today, and also make our time to attend tomorrow again by God's grace, 5 to 6. So it's time for question and answer. Question and answer.
All right. Can you hear me, sir?
Yes, I can hear you.
Okay. Thank you for your time. My question is assuming I created a table that has up to 5 different items or entity. Then after creating it, I discovered that I need to add extra 2 entity to it. Is that possible?
Extra entity or extra column. Entity is record that you are entering. You can keep on updating, adding more record to your table. Is it extra column?
Okay.
Do you mean column or what?
I mean extra column, yeah, extra column.
Yes,
Like I want to add extra
Yes.
outside. I want to add extra column after I've created the table. It's possible.
Yes. You can add. I think we have somebody asked that question last week. So we have not gotten to that level. That's why I have not shown you. I think we have a code like that last week. Maybe I have deleted it. I didn't. You can add it. We'll go to that one later. We are trying to take it step by step. When we finish this relationship now, the next thing is inserting record into our table. All these tables we have created, we have to populate it. You understand? We have to write code and populate it. When we populate it, the next thing is to, how can we see what we have populated? Then at that time now we can make adjustment now. Let's say we want to remove a column, we want to add column. When we get into operation now, we discover some columns are missing. We need to add So we will still go to that one. We have done introductory aspect of that. We look at the two SQL language, categories of SQL language, which we have the DDL, the data definition language. We have the DML, the data manipulation language. So what you're asking is about data definition language. So we'll still go into that one. Another question. Another question again. So it's already 5:20 now. So thank you. We have successfully come to the end of today's session. By tomorrow, by God's grace, we'll continue again.